Okay, good morning, Professor David J. De Los Reyes. Okay, my session or my subject matter for this session will be the concepts of binomial theorem with the help of Pascal's triangle. Okay, let's proceed. Binomial theorem with the help of Pascal's triangle. We got a problem. Find the coefficients of the expansion of 2 plus 3 raised to the 4th power and its value. The problem is asking for the coefficients of the expansion and the value. The coefficients meaning these are the coefficients. Example, if the power of n is equal to 2, the coefficients of the expansion will be 1, 2, and 1. If the power n is equal to 3, the coefficients of the expansion will be 1, 3, 3, and 1. So the problem is just asking for the coefficients of the expansion. We are given the binomial 2 plus 3 raised to the 4th power. Okay, let's try to bring out the solution. The solution will be by using Pascal's triangle. Under binomial theorem, the total number of terms will be equal to the value of n. The value of n plus 1. That is a general rule. Whatever the value of n, you add 1, that will be the total number of terms in the expansion. I will give you an example. If the value of n is equal to 2, okay, the total number of terms in the expansion will be 3. That is 1, 2, 3. Right? So if the total number of terms is 3, okay, or the power n is 3, the total number of terms will be 4. That is 1, 2, 3, 4. Okay, let's try to bring out the solution by using the Pascal's triangle. Okay, to make it simpler to find the value of the coefficients. If we try to construct the Pascal's triangle, it will be something like this. This is 1, 1 and 1. 1 plus 1 is actually 2. We put again 1 here. We put 1 on the right side. 2 plus 1 will be 3. And 2 plus 1 will be 3. This is 1, this is 1. So the next values will be 1 plus 3 will be 4. 3 plus 3 will be 6. 3 plus 1 will be 4. This will be 1, this will be 1. The next one will be 1 plus 4 will be 5. 4 plus 6 will be 10. 6 plus 4 will be 10. And 4 plus 1 will be 5. This is 1 again. This one. The next one. 1 plus 5 is actually 6. 5 plus 10 will be 15. 10 plus 10 will be 20. Okay. 10 plus 5 will be 15. 5 plus 1 will be 6. And this is 1. And this is 1. Okay. It will be something like that. So actually by just constructing the Pascal's triangle, we could determine the coefficients of the expansion. Okay, so for the given problem, the value of n is actually 4. So actually we are on this portion here. The one I underlined with the orange marker. The value of n for the given problem is n is equal to 4. So the coefficients for each of the terms will be 1, 4, 6, 4, and 1. And the total number of terms on the expansion will be 4 plus 1, it will be 5. So this is 1, 2, 3, 4, 5. Okay, let's try to get the values of the given binomial. If the coefficient is 1, the first expansion will be 1. This is the coefficient that is being asked by the problem. 1, okay. the first value is actually 2, right? And the value of n is actually 4. So this will be 4. Okay? Times 3 raised to, this will be 0. For us to be correct, the sum of these will always be 4. Right? So meaning the coefficient of the first term will be 1. Where that 1 came from, it came from this. Right? 2 to the 4 times 3 to the 0. And for us to be always correct, the sum of the exponent of the first term and second term will always be equal to the given n. So simplifying this one, 1 times 2 to the 4 is 16, 3 to the 0 is 1, 16 times 1, the first expansion will be 16. It is just the value 2 raised to the 4th power. Okay, that's 16. The second value, the coefficient will be, from our Pascal's triangle, the coefficient of the next term will be 4. So this is 4. Okay, times 2 to the 3rd power. We are decreasing in value because we started with 4, right? So 4 minus 1, this will be 3. Times 3 raised to the first power. And if you try to notice it, the sum of 3 plus 1 is again 4. For us to be correct. So simplifying this one, 4 times 3 will be 12. 2 cube is 8. 12 times 8 will be 96. So the second part of the expansion is 96. Okay? And the coefficient is 4. And this 4 here emanates from the Pascal's triangle. The third one will be, the coefficient will be 6. So this is 6 times, the first term is actually 2, right? This is 3. 3 minus 1 will be 2, so this will now be 2. You notice it, the powers of the first term is actually decreasing, and the powers of the second term is increasing, right? So this is 2 times the second term, which is 3. If this is 2, this should be 2, because the sum of the two terms, sum of the two exponents will always be 4. Right? So if we try to simplify this one, this will be 6 times 9 times 4, which is 216. So the third part of the expansion is actually 216. Okay? Next one. We are now through with this, right? We are on the fifth one. The coefficient of the fifth term is actually 4. It emanates from the Pascal's triangle. So this is 4. The first term is 2. The power now will be 2 minus 1, which is 1. The second term is 3. So if this is 1, this should be 3, because the sum of 1 and 3 will always be 4 for the given problem, right? And if we try to simplify this one, this will be 4 times 2 times 27. What comes out is 216. That's the fifth term. And the last one is actually, the coefficient is 1. Right? So this is 1. The first term is actually 2. This is 1. So 1 minus 1 minus 1 is 0, right? So this will become 0. The powers of the first term is actually decreasing and the powers of the second term is increasing. And the sum is always equivalent to the given n. So if this is 0, the second term will be 3, the power will be 4. Because a 0 plus 4 is still 4. You notice it, the sum of the terms of the first and second term for all the discussions or the solution. This is 4, 4, 4, 4, and 4. Right? For the first term, it is decreasing. For the second term, it is increasing. Right? It starts with 0, 1, 2, 3, and 4. For the first term, it is decreasing. 4, 3, 2, 1, then 0. 2 to the 0 is actually 1. So 1 times 1 is 1. 3 to the 4 will be 3 to the 4, and that is actually 81. Okay? So the expansion of the given binomial 2 plus 3 raised to the 4th power will be the summation of A plus B plus C plus D plus E. This represents A, the coefficient 1, 4, 6, 4, and 1. 1, 2, 3, 4, 5. So the total number of terms for the expansion is 5. So we are correct. Right? So if we try to get the value of the given binomial now, it will be 16 plus 96 plus 216 plus 216 plus 81, and the value is actually 625. We could check it. 2 plus 3 is 5, right? To the fourth power. But 5 to the fourth power can be written as 5 square, then square again. So this is 25. 5 square is 25. Then we square it again. 25 square is actually 625. So this is correct. So the solution of the problem by using the Pascal's triangle will be this. Okay, the shortcut solution will be this. But if we are on the topic of binomial theorem, with the help of Pascal's triangle, this will be the solution. Good evening from Los Angeles.